Hello everyone. So in today's video we will discuss about methods by which the efficiency of the Brayton cycle can be improved. So what are the methods by which I can improve the efficiency or the work output of the Brayton cycles are? There are three methods basically. The number one is regeneration. By using regeneration you can increase the efficiency. Number two is by intercooling. By intercooling you can increase the work output, even the efficiency. And number three is the reheating. We shall study all these methods one by one. Firstly, the regenerative gas turbine cycle. How regeneration helps us in increasing the efficiency of the gas turbine, we shall first understand by this schematic diagram as well as the TS diagram given below. Okay, so as in case of a normal gas turbine, there is a compressor, there is a combustion chamber, and there is a turbine. Compressor from 1 to 2 dash where compressive process takes place. Again from 2 dash to 3 the heat addition process takes place, and 3 to 4 dash where the expansion process takes place. This is a general gas turbine cycle, is it? Now what are you doing is, whatever heat which is remaining at the outlet of the turbine, that is used back to the cycle. How? Now this heat is taken back here. Now the heat is available at the 4 dash, correct? So this is 4 dash. Now the heat is available at the 4 dash. This particular heat is being transferred to the incoming gas to the combustion chamber. Combustion chamber is the slot where you will be adding up the heat, is it? So that particular addition of heat is supported more by adding the heat from the outlet of the turbine. So generally outlet of the turbine will be having the waste heat, is it, which is not used anywhere, but that particular heat is now reused to heat up a little bit. That is from suppose the turbine outlet is at state 2 dash because of inefficiency. Remember it, because of the actual cycle, in the ideal cases, so it must be 1 to 2. Because of the inefficiency of the turbine, it is from 1 to 2 dash. This is general concept, right? So from 2 dash to 5, see here, from 2 dash to 5, you are increasing the temperature from 2 dash to 5 here because of the regeneration. From 5 to 3, again it is because of the combustion of the gases, the heat is added up in the gas turbine. Okay, similarly from 3 to 4 dash will be there is a expansion process. From 4 dash to 6, whatever heat is remaining at the outlet of the turbine is being given to the gas which is coming input to the combustion chamber. So from 4 dash to 6, heat lost is this particular thing. It's from 4 dash to 6. So heat gained because of the regeneration is 2 dash to 5 by losing the heat from 4 dash to 6. Now if you observe the quantity of heat which is ejected from 4 dash to 6 is being absorbed from 2 dash to 5. That means there is no loss or no gain in this process. Therefore, the work output of the regenerative gas turbine remains same. But the thing is, what you are doing is you are increasing the QS. QS is amount of heat supplied. Generally, it was from 5 to 3. Now we are increasing from 2 dash to 5 plus 5 to 3. You're increasing the heat supplied. So the efficiency of the regenerative gas turbine would definitely increase. So the notes for this particular thing would be presented here. You can just pause it and write down the notes for it. At the last, you'll be having this effectiveness of a regenerator. What is this effectiveness for a regenerator? Effectiveness is a word used for generally the heat transfer medium, heat exchangers. So the heat exchanges efficiency is always known as effectiveness. How do you measure it? It is a ratio of actual heat transfer divided by maximum possible heat transfer. Okay, what is that actual heat transfer? What is that maximum possible heat transfer? See, actual heat transfer is given by T5 minus T2 dash, and the maximum possible heat transfer is given as T4 dash minus T2 dash. What is it? We will see that. Okay. See, listen here. What is the actual heat transfer happening? the heat is getting increased from T2 dash to T5. So actual is T5 minus T2 dash. Now, what is the maximum possible heat transfer? The temperature at T2 dash can increase maximum until where? Until this particular temperature, which is here, T4 dash. So beyond that, it cannot increase. If this is only 90 degrees Celsius, assume it as 90 degrees Celsius. If this is of 20 degrees Celsius, it cannot gain the heat more than 90 degrees Celsius, is that? So the maximum possible heat transfer could be T4 dash minus T2 dash. But actually it is how much? T5 minus T2 dash. This is how. You don't worry about this. You'll get to know while you are solving the problems. So once again, I will focus this particular thing. So complete the notes and finish this. Okay.